In our lesson 2.11.a today, we will be graphing quadratics in standard form. Our objectives are to find the axis of symmetry line, find the vertex, and then graph a quadratic in standard form. So if you can remember, the axis of symmetry is that imaginary line that passes right through the vertex and splits the parabola into two symmetric halves. So let's look at the axis of symmetry a little bit more. The x-coordinate of the vertex, and here is our vertex, let's highlight that, right here. The x-coordinate of that, so the x-coordinate of that is 2, the y-coordinate would be 1, but the x-coordinate of the vertex is always going to be the equation of the axis of symmetry of the parabola. So since the vertex of the parabola is 2, 1, the axis of symmetry line would be x equals 2. So knowing either one of these can get you the vertex if you know the axis of symmetry, or the axis of symmetry if you know the vertex. Okay, so our axis of symmetry line would be a dotted, invisible line that passed right through the vertex and again splits our parabola into two symmetric halves. So let's look at how we might find the axis of symmetry in standard form. In standard form, it's not as simple as vertex form because you can't see the vertex and therefore the line of axis of symmetry. You have to do a little bit of work. So for a quadratic function in standard form, which is again y equals ax squared plus bx plus c, the axis of symmetry is a vertical line at, and here's a little equation. It's not that difficult and you can write it down in your notes, and I would highly recommend that you write it down in your notes so you can access it when you need it. But again, remember we said it was the x-coordinate. So the x-coordinate is equal to negative, and then we pull the b value divided by 2 times the a value. So negative b over 2a will get us the equation for the axis of symmetry. So let's practice that. Let's look at these two equations here and let's try that. Find the axis of symmetry of the graph of this quadratic in standard form. Well, let's go ahead and fill in what we know. So x is equal to negative. Always remember to put that negative. And then let's find b. You know what, actually let's go ahead and find a, b, and c again so that we make sure we are pulling the right coefficients and the right constant terms from this equation. So our a value, remember, is in front of the x squared. I don't see anything there, so I know it's a 1. The b value is in front of the x, which is a negative 6, and the c value, which I don't actually need right now, is 5. That's your constant term. Going back to our equation for the axis of symmetry, it's x equals negative b. Well, b is negative 6, so I've got a double negative here, divided by 2 times my a value, which is just 1. So let's go ahead and simplify. A negative times a negative is a positive, so that leaves 6 over 2 times 1, which is just 2. 6 is divisible by 2 evenly, and that equals 3. So the equation for the axis of symmetry for this line is x equals 3. Now let's look at the second equation here. Let's go ahead and pull off our a, b, and c values just to be proactive. Our a value, again, is the term in front of the x, and I don't see anything, so once again it's going to be 1. Our b value is in front of the x term, so that's 12, and our c value is our constant term, which is just 32. Okay, so again, remember the a value is in front of the x squared, the b value is always in front of the x, and the c value is always your constant term. Using our equation for the line, for the axis of symmetry line, we have x equals negative, and our b value is 12, over 2 times a, and our a value is 1 once again. So let's simplify. We'll keep the negative since that's our only negative. 2 times 1 is just 2, so 12 divided by 2 is 6. So the equation for the line for the axis of symmetry is x equals negative 6. All right, let's take it to the next step. Let's go ahead and find the vertex knowing the equations for the axis of symmetry. So on our first graph, we found the equation, and I'll go back, to be x equals 3. So if we write that in here, we have x equals 3. So think about how we might find the vertex if we know that x equals 3. Well, remember that in a graph, if we go to where x equals 3 and we draw that imaginary line, so we have 1, 2, 3, our vertex intersects this imaginary line somewhere. It could be up here, it could be down here, it could even be here on the x-axis. So what we don't know is our y value. We don't know if it's up here at 5, right here at 0, or down here at maybe -4. We just don't know. That's a question mark. But we do know the x value. And you guys, if you remember doing your systems of equations, you remember how to take a value and substitute it in to find another value. So if I take my 3 and I substitute it into my equation for x, I replace all my x's with 3, then I can find out my y value when x is 3. So let's go ahead and do that. So what I have then is y is equal to 3 squared minus 6 times 3 plus 5. So now I just have the variable y. So if I simplify this, I'll know what my y value is when my x value is 3. So let's go ahead and do that. So y is equal to, we do our exponents first. 3 squared is just 3 times 3, which is 9. Minus, and we do our parentheses multiplication next. So 6 times 3 would be 18. And then plus 5. So now we just work from left to right, adding and subtracting. So y is equal to 9 minus 18 is -9. And then we have our plus 5. So for our final answer, we have y is equal to -9 plus 5, and -9 plus 5 gives us -4. So now we actually know what the vertex is for this quadratic function in standard form. In fact, it is down here. It's at 3, -4. So that's our vertex for this first one. Let's go ahead and apply what we learned to the second one. So if you want to try to find the vertex, go right ahead. Remember that our axis of symmetry for that one, we found that to be a -6. So I'll go ahead and write that in there. X equals -6. So we can use that. Go ahead and see if you can find the y value. Okay, so hopefully what you did is you took y equals, and I'm putting this in parentheses because of the negative, -6 squared plus 12 times -6 plus 32. So if we simplify this, a -6 times a -6 is a positive 36. A -6 times 12 is -72 plus 32. Okay, simplifying it a little bit more, 36 minus 72 is -36 plus 32. And finally, -36 plus 2 is -4. Now we have the vertex. Our vertex is at -6, -4. So now I know my vertex. So let's think about what we did. We first found the equation for the line for the axis of symmetry. And once we knew our x value from that, we were able to plug it back in order to figure out our y value, which would tell us our vertex. Now let's go to our final step here. Let's put it all together and let's graph what we know. So here's our first equation, and we found our vertex, and we can go back and look, to be 3, -4. So our vertex is 3, -4. Let's plot that. 3, -4 is right down here. And remember that we have an imaginary line going through that. That's our axis of symmetry line. right here. Okay, and it's invisible, but we know that it separates our graph, our parabola, into two congruent pieces. So we have our vertex, we have our axis of symmetry. What we need now are some additional points. Up here it says, for a quadratic function in standard form, to graph it, find the axis of symmetry, which we did, the vertex, which we also did, and then a couple of points on one side of the axis of symmetry using a table. So we don't need a lot of points, we just need a couple of points. Let's go ahead and make a table. Now the key here is we want to find a couple of points on one side of the axis of symmetry. And if you think about why, because if we know a couple points on one side, then we know we can mirror those on the other side since the parabola is symmetric on both sides. Let's go ahead and pick some points. Well, I would pick 0 because that's a very easy point to plug into our equation. And then we can just pick another point. So maybe we'll pick 0 and 1. So if we plug in a 0, well, 0 squared is just 0. And 6 times 0 is 0, plus 5. So y would just equal 5. And see how nicely that comes out if we can choose 0. Now let's try 1. So we've got 1 squared minus 6 times 1, which is just 6, plus 5. We might need to do a little bit of simplification there. 1 squared is just 1. 1 minus 6 is negative 5. And negative 5 plus 5 is 0. So y is 0. Okay, I think we're ready to plot these points. So we have a point at 0, 5, which is here. We also have a point at 1, 0, which is here. I've plotted these 2 points. I can now plot points that are symmetric. So 1, 2 to the line and 1, 2 over means I can plot here. Same with this one, 1, 2, 3 over to the line, 1, 2, 3 this way means I can plot here. Therefore, now I can connect my dots and I have my parabola. All right. Let's go ahead and graph the other one. So let's remember that the vertex on the other one we found to be negative 6, negative 4. So we'll go ahead and write that. Our vertex was negative 6, negative 4. So let's plot that point. That's down here. And let's go ahead and draw in our axis of symmetry line. That'll make it easier to graph our other points. All right, well, we know that we need a table of values. And again, we only need a couple. That's the advantage of graphing a parabola, is that we only need one side of it because we can just mirror the other side. So if I look at where I am, I think that maybe I'll go to the right, and I can again choose 0 if I want, but it's pretty far over, so I'm not sure I'm going to do that. Perhaps I'm just going to choose maybe a negative 5 and a negative 4. I don't want to get too far away from my vertex. If I get too far away, the potential is I'm going to get a really high y value. And if you look at this equation, if I plugged 0 in for x, I would get 0 plus 0 plus 32. So I'd get a y value of 32. And my graph doesn't go to 32. It's not that I couldn't plot it, it's just that I want to keep it somewhere on this graph. So let's go ahead and try the negative 5. So here's what we have. We have negative 5 squared plus 12 times negative 5 plus 32. So it's going to require a little bit more work from us, a little bit more math, but we can do it, and you can always use a calculator. So finishing this up, what I'm going to end up with is a negative, let's see, 35 here, plus 32, which will give me a negative 3, it looks like. and that's a reasonable number that's on my graph. So I squared -5 and got 25. I multiplied 12 times -5 to give me this 60, and then I have my 32. And that's how I started off. Okay, let's go ahead and try the -4. So there's our first point. So now we have -4 squared plus 12 times -4 plus 32. So I get 16 minus 48 plus 32, which that then gives me 32, -32 plus 32, which equals conveniently 0. And that's a nice number. And again, if you choose a number that gives you a big y value, you can always go back and re-choose if you want to. I am choosing my x values completely randomly, except for that I'm keeping in mind that I want them to be somewhat close to my vertex. All right, let's graph. -5, -3 is right here, and -4, 0 is right here. And then I can plot these symmetric points on the other side, and I'm ready to draw my parabola. All right, and I'm finished. So let's try one more, and I would encourage you to pause the tape and try this one. Since this is a brand new one, then we'll have to do each step one at a time. So if you'd like to, go ahead and pause, try to find the axis of symmetry, the vertex, and then graph it on your own. Okay, so if you're coming back, let's go ahead and find the axis of symmetry. So that would be our step one, our axis of symmetry. We know it's going to be x equals -b over 2a. An easy way for me to figure that out is to go ahead and label my a and my b, and I'll label my c just to keep me refreshed. My a is going to be -2, my b is going to be 8, and my c is 1. Now I'm ready to plug those in. So we have -8 over 2 times -2. So let's go ahead and simplify. We're going to get -8 over -4. 2 times -2 is -4. Now I have a negative divided by a negative, which is going to give me a +2. So now I can go ahead and graph the equation for my axis of symmetry line, and it's going to be at 2. So let's go ahead and put that there. We know that. That's step one. Now let's find the y value. So we're going to plug in 2 in place of x. So we have -2 times 2 squared plus 8 times 2 and then plus 1. And all we need to do now is simplify. So be careful to do the exponents first. 2 squared is 4. Do not multiply the -2 times the 2 because you'd be out of order when you're thinking of PEMDAS. We have parentheses, but there's nothing to do in the parentheses. Next step is exponents. And then after that is your multiplication and your division. So make sure that you simplify that exponent first. 8 times 2 is 16. We can simplify now with our multiplication. -2 times 4 is -8 plus 16 plus 1. That gives us then 8 plus 1, which gives us 9. Now we know what our vertex is. So step 2, our vertex is going to be 2, 9. Let's go ahead and plot that on the graph. So here we are at 2, 9. So we're pretty far up. Okay, so our final step then is just to go ahead and make a table of values. So we'll do that next. 3 would be our table in order to graph this quadratic. Okay, let's go ahead and pick some x values. I will want to look where my vertex is, and it's here at the 2. So I want to pick some x values close to that and something that I can plug in very easily. Let's go ahead and pick a 1 and a 0. Those would be great ones. So let's try a 0 and let's try a 1. Going to my equation, if I plug in a 0 here for my first term, 0 squared is just 0, and 0 times -2 is going to be 0 as well. If I plug in a 0 for this x, 8 times 0 is also 0. So what I end up with is 0 plus 0 plus 1, which is just 1. Now let's go ahead and plug in a 1. So we have -2 times 1 squared plus 8 times 1 plus 1. In this case, 1 squared is just 1, and 1 times -2 will be -2. 8 times 1 is 8, and then I have plus 1. -2 plus 8 is 6, and 6 plus 1 is going to give me 7. So when I plug in a 1 into my equation, my y value is 7. I can plug these points onto my graph, or plot them, I should say. So let's plot the first one at 0, 1 right here, and the next one at 1, 7 right here. I'll go ahead and plug my symmetric points here, and then I can connect my dots and draw in my parabola, and I have now graphed a quadratic in standard form. One thing I do want to point out to you is notice the negative in front of the a value. Remember what the negative does in vertex form, or even on a absolute value equation or on a linear equation. It's a transformation, it's a reflection. And this is going to hold true in standard form too. Notice that our graph now opens down. Anytime that a value is negative, you can predict that the graph is going to open down. All right, and that concludes our lesson on 2.11a, graphing quadratics in standard form. So let's go ahead and look at what you learned today. You learned how to find the axis of symmetry line using -b divided by 2a. You learned how to find the vertex in standard form by taking that x value and plugging it back into the equation to find y. And then you learned how to graph a quadratic in standard form by plotting the vertex, the axis of symmetry line, and then making a table of values in order to plot a couple of points on one side. All right, try the practice and assignment on your next page or two.